Well, now we're going to do question exercise 2 on revision of linear number pattern for grade 9. From grade 9, question A says for each of the following number patterns, determine the general rule and hence the 10th term. Now let's start from question 1. We see here we have like 2, 4, 8, 16. And then this pattern tells me like those are powers of 2, okay? Because this is 2 to the power of 2. 4 is like 2 squared, okay? 8 is like 2 to the power of 3. 16 is like 2 to the power of 4. And guess what should be 2? 2 to the power of 1, because anything times the power of 1 is that itself. So here we can say Tn is just equal to 2 to the power of n. That's all. And then the 10th term would be like, we're going to substitute n by 10, so that makes 2 to the power of 10, which is 1024. Okay, question 2, we have like 1, and then 3, and then 9, and then 27. So what we see here, it's similar to question 1. 3 is like, okay, 9 is like 3 squared. 27 is 3 to the power of 3. What about 3 itself? 3 to the power of 1. And what about 1 is 3 to the power of 0. So in this case, because we have a 0 here, because the position 0 doesn't make sense in pattern. So pattern, when we talk about number pattern, we're talking about the position. The position must be a positive integer starting from 1. So in this case, I will say like Tn would be equal to 3 to the power of n minus 1, okay? Why I say n minus 1? Because if n is 1 for the first term 1 here is the first term. This one here is term number 1, that's term number 2, and then term number 3, and term number 4. I said that because for the first term, T11 n is going to be 1, we'll have 1 minus 1, which is 0, and then 3 to the power of 0 will be 1. Okay, so that's why I say n minus 1. So this will be valid for the rest, and then we can do can say that T10 will be equal to 3 to the power of 10 minus 1, which means T10 will be equal to 3 to the power of 9. Okay, I prefer to leave it like that. Question 3. Let's see here, what do we have? We have like 4, and then 12, and then 36. Okay, when I see here from 4 to 12, we times by 3, and then 12 to 36 we also times by 3. So we have like we don't have a constant difference here, but here we have a constant ratio, okay? Because we times, it's increased by the ratio of 1 to 3 all the time. So 4, and then times by 3, 12, and then times by 3, 36. Now, what can we do here? Let me rewrite it over here, okay? I'm writing it 4, 12, and then 36. I said it's increasing by a ratio of 3. So, so if you look at 12 here, it's like 4 times 3, okay? And then some also at 36 is 12 times 3. Now, because we times over here, we times by 3 all the time. We times by 3 from 4 to 12. From 4 to 12, we times by 3. And then from 12 to 36, we times also by 3. Now, because of that, I prefer to break it up into form like 3 times 3. Then I can also say, I can say this. You see that from 4 to 12 we times by 3, and then from 12 to 36 we also times by 3. Meaning, if I need to write the pattern here, I'll say here. You see, to get the third term, I times by 3 twice. Times by 3 times by 3. So like 3 to the power of 2. Okay, to get the first term, the third term. To get the second term, I'll times by 3 once. So it's like 3 to the power of 1. If there were a fourth term here, I would have times by 3 times, and so on and so forth. But we're starting from 4. Okay. Therefore, here the pattern would then be Tn would be 4, the initial 4 here, and then times by 3 to the power of n minus 1. So you can check it here. 4 here would be like 4 times 3 to the power of 0. Okay, this will be 3 to the power of 1. Even 12, even this one will be 4 times 3 to the power of 2. 36, and then you notice that we start with 4, and then 3 to the power of 0, 3 to the power of 1, 3 to the power of 2, and so on and so forth. So my pattern here will be 4 multiplied by 3 to the power of n minus 1. N minus 1 because the first term is 0. In case we sub 1 there, 1 minus 1, we're going to get 0. 3 to the power of 0 will be 1. 4 times 1 is just 4. That's the first term. If it's for the second term, we sub 2 for n. 2 minus 1 is 1, 3 to the power of 1 is 3, 4 times 3 is 12, that's the 12, and the same also for that. In case this seems complicated, I'll give you a formula for this type of pattern is called a geometric pattern, okay? I'll write it here, over there. The geometric pattern is given by this Tn equal to a r to the power of n minus 1, okay? Where r here, the R stands for the constant ratio. Constant ratio. Over here, the ratio was times 3 all the time. So we can just say Tn will be, okay, I say R is the constant ratio, and then A is the first term, T1. So you can say A is the first term, T1, so 4, multiplied by R, the constant ratio, which is 3 to the power of n minus 1, n minus 1. This is a formula to get this sort of pattern. It's called geometric pattern, okay? You see a lot of it in grade 12. Question 3, that was question 3. Just it here, and then question 4, what's that? It's 32, 16, 8, and then 4. Again here, we notice that this pattern is it's like from 32 to 16. We actually divide by 2. Here we divide by 2, and then we divide by 2. Divide by 2 is the same thing as multiply by a half, okay? So we can apply the same technique as we did here, or if you want to use the formula for the geometry pattern, because you can notice that there is a constant ratio, then we can say, okay, because Tn, the formula is already there, I don't need to write it again. Tn is a r to the n minus 1. Know that a is the first term, r is a constant ratio, so here we can just say Tn will be equal to a, the first term is 32. The constant ratio is a half, so divide by 2 means a half. So we're going to write a half, okay? Divide by 2 means times by a half, okay? Let's just keep it like times by a half. If you times 32 by half, it's 16. 16 times by half, it's 8. 8 times by half, it's 4. So we're going to say a half to the power of n minus 1. Now, it's always better to simplify, you know. 32, you can write 32 in terms of its prime factor. It's going to be like 2 to the power 5. If you're unsure, you can do the tree diagram, or the 3 factors, or you can use a calculator, type 32, and then press equal like this over here, and then press this button here, shift, and then press the button equal. Press the button fact, okay? And then tells you it's 2 to the power 5. Now, a half can also be written as 2 to the power of -1 or to the power of n minus 1. Now we can times, okay, these exponents. This makes Tn will be equal to 2 to the power 5, not 25. Multiplied by 2 to the -n plus 1. Now that the bases are common, you can just add the now that the bases are common, we can just add the exponents, so it's going to be like 2. Remember, I said that because there is a law of exponent that we learned that says that a to the m times a to the n equal to a to the m plus n, okay? So over here, we're going to add 5 plus 5 minus n plus 1, which means Tn equal to 2 to the negative n plus 6. Okay, that's actually simplified form of this question. Now we can do question 5. Question 5, the patterns are -2, -6, -18. And again, notice there is a constant ratio here with times by 3 all the time. So you can apply that formula. I'm going to write it again here. Tn Tn is a multiplied by r to the power of n minus 1, okay? Where I said a is the constants. No, a is the first term, T1, and then this is just a constant ratio, okay? Constant ratio. So we can substitute from using this formula. By using this formula, Tn will be equal to, the first term is -2, and right here -2, and then the constant ratio is 3. So I don't really need to put bracket there. -2 multiplied by 3 to the power of what? N minus 1. Now that's it. We cannot simplify this, so it's going to be like that. Now let's continue. Question 6. The given pattern are 𝐻, and then 1, and then 2, and then 4, and etc. Again, here, notice from 𝐻 to get 1, we times by 2. From 1 to get 2, we times by 2. There, we times by 2. Now, we're going to apply this formula in red. So we're just going to say Tn will be equal to, what is the first term? It is 𝐻. What's the constant ratio? It's 2. So 2 to the power of what? N minus 1. Now we can write it even better. Simplify this. Tn 𝐻 can be written as 2 to the -1. Remember, 1 over a to the m equal to a to the -m. There is an invisible exponent here of 1. So we can write it as 2 to the -1. Then we multiply by 2 to the n minus 1. Then we can simplify. Okay, this makes 2. Applying the law of exponents, when they have common basis, we add the exponent. So it's going to be like -1 plus n minus 1, which means that Tn is just equal to 2 to the power of n minus 2. That's the simplest form of this. Okay. 7. We have 16, and then 4, and then a quarter. No, 1, and then a quarter. Again, we're going to apply that formula and write it here again. Tn equal to a r to the n minus 1. Okay, so you notice that over here we divide by 4. Divide by 4 is the same thing as times by a quarter. Okay, we divide by 4 means we times by a quarter. We divide by 4 means we times by a quarter. So in cases like this, this is the formula as in the previous questions, some of them. Over here, what we do, Tn will be equal to the first term, which is 16, multiply by r, which is a quarter, to the power of n minus 1. Now we can write it, simplify this, because we can. Tn will be equal to 16 is 2 to the power of 4, and the quarter is 1 over 2 squared to the power of n minus 1. Then 2 to the power of 4 times 2 to the -2 to the power of n minus 1. We apply the formulas we used over here on 1 over 2 squared, okay? And then in this case, we times the exponents. So this will be Tn will be equal to 2 to the 4 multiplied by 2 to the negative 2 plus 2. In this case, what we do, Tn will be equal to, we add the exponents, okay? 2n, say 2n there, I missed to write my n, 2n plus 2. Careful, when you times here, negative 2 times n makes negative 2n. Negative 2 times negative 1 also, usually we miss that, okay? Makes positive 2. So this makes 2 to the power of negative 2n plus 6. Okay. Question 8, same thing. It is given like a half and then 1 over 4, 1 over 8, 1 over 16, etc. Okay, so over here, we can do it a bit differently. Remember, you can see that the denominator is common. We can just work out the denominator here. We see that's common. I mean, it's 2, 4, 8, 16. Question 1, we had a question like that where we have like patterns like 2, 4, 8, and 16. Of course, it also follows the formulas we did. Say this is times by a half. If you can't perceive it, try to do this. You first take a quarter, the second term, okay? Divide this, okay, by a half, the first term. And then see the answer is a half. So it means we times by a half. Try again with just 1 over 8, okay? The third term, divide that by a quarter, okay? 1 over 4. And then see what the answer is, a half. So it means it will have here a constant ratio of a half all the time. Okay, so we can say as we did here, okay, and following this formula, or we can also see in question 1 we did work out that already. Question we did find that it was just 2 to the power of n. Okay, we did the denominator here. You see 2, 4, 8, 16. We find it was 2 to the power of n. So you can apply the formula or just say Tn will be equal to 1 over 2 to the power of n. Okay. If you work out the denominator, you see that the pattern, this will be 2 to the power of n. And then you can say Tn will be equal to 2 to the negative n. That's easy. And then we can substitute to find the 10th value sub by 10 to get the answer. Or you can leave it like this, okay? It's still gonna give still correct. Number 9 is 27, 7, 7 and the quarter, 7 over 4, and 7 over 16. So that was 28. So I can see that from 28 to 7, we here divide by 4 or times by a quarter. If you're unsure, do 7, divide by 28. So always a term divide by its previous. You see it's going to be a quarter. And then 7 over 4 divided by, it's going to be another quarter. So we times by a quarter here. Or we divide by 4. Each term is the previous term divided by 4, which means we times by a quarter. Then we can apply our formula that says Tn equals to Rn minus 1, where A is the first term, R is the constant ratio. So here Tn will be equal to what? 28 multiplied by a quarter to the power of n minus 1. Okay, 28 is not really an exponential number of base 2, so we're gonna leave it like that. Okay, or we can simplify further. This will be Tn will be 28 will be it's like in terms of a prime factor, it's 2 squared times 7 multiplied by a quarter is 1 over 2 squared to the power of n minus 1. Okay, and then Tn will be equal to 2 squared times 7 multiplied by 2 to the negative 2 all to the power of n minus 1. Now, if we times the exponents here, say if we times exponents, we get Tn equal to 2 squared times 7 times 2 to the negative 2n plus 2. Okay, and then we can combine the exponent there with the 2. Okay, I'm talking about this and that one. So this will be just like 7 multiplied by 2 to the negative 2n plus 4. This is the simplest form, and then we can substitute 10 there and then 10 by n to get to find the value. Okay, thank you. Well, now we have another question here, question B. In exercise 2, revision of linear number pattern, grade 10. Question says, for each of the following sequences, determine the nth term and hence the 100th term. Okay, let's start with question 1. You notice that we have like 1, 4, 9, 16. Unlike the first question is, here we don't notice any constant ratio. But what we can notice here, each term here are square numbers. Like 1 is a square number, 4 is a square number. So as they are, like 1, 4, 9, 16. Okay, semicolon, semicolon, semicolon. They're square numbers, all of them. 1 is 1 squared, 4 is 2 squared, 3 squared, 4 squared. So we can just see here Tn will be equal to n to the power of 2. Okay, so to find the 100 terms, we can just say this is 100 raised to the power of 2, which means Tn will be 10,000. Okay, and then question 2, 2, 5, 10, 17. Okay, this time we don't see a pattern, like we cannot say it's +3 because the following can be +5 and then +7. So let me rewrite it here so we can see it clearly. 2, 5, 10, and then 17. You notice that there is a constant difference here. No, not a constant difference, but the difference is 3, 5, and then 7. And there is another difference here, which is constant now. Now, this is the type of pattern we call the quadratic pattern, when the second difference is common. Okay, the first difference will make a linear pattern, and the second difference will be common. We call it quadratic pattern. Now, we'll do that a lot of them in grade 11, but now in grade 10, what we can do here is we're not going to do the formulas that we will do in grade 11, but I want you to notice that in cases like this, look at each term. Okay, there are like one unit, one more than the square numbers. If you look here, this 2 is like 1 squared is just 1 squared plus 1. 4 is like 2 squared. I mean 5 is like 2 squared, which is 4 plus 1. And then 10 is like 9 plus 1. 9 is what? Is 3 squared plus 1. And then 17 is 16 plus 1. 16 is 4 squared. And then plus 1 makes 17. So we can say here that the pattern Tn will be equal to what? We're going to say n squared plus 1. So it is a square number added 1 to it. Okay? Let's see question 3. We have like 4, and then 7, and then 12, and then 19. Now, over here, we can't really do much with 7 here. I can say 4 is 2 squared, but 7 and 12 and 19, not really. But if you look at this carefully, you notice that okay, we can say there are 6 square numbers there, but plus a certain number, like 7 here would be like 4 is square number plus 3. Okay, 12, let me write the different color so we can see. It is like 4 plus 3 there, and then 12 is also like another square number that comes after 4 is 9, so it's like 9 plus 3. Okay, and then 19 is also another, the following square number 16. After the square numbers in order, in ascending order, there are 4, 9, 16. So 16 plus 3. So guess what should be by 4 there? It's going to be like another square number 1 plus 3. Because I say 1 because here 1 is like 1 squared, 4 is 2 squared, 9 is 3 squared, and then 16 is 4 squared. So from there we can say Tn will be equal to n squared plus 3. Okay, you can check if you sub 1 there, 1 squared is 1 plus 3, 4. Sub 2 there, 2 squared makes 4, 4 plus 3, 7. Okay, sub 3 there, 3 squared is 9, 9 plus 3, 12, and so on and so forth. Okay, and then question 4, we have like 5, 8, 13, and then 20. Okay, so let's look at it. Now, when I look at these terms, 5, okay, I can say, I can notice that over here, it's like 1. I'll take a square number first, okay? The first square number is 1, okay? 1, and then it's plus 4 to get 5. And then here, this following square number is 4. After 1, the next square number is 4, and then 4 plus 4 makes 8. The following square number here will be 9. So 9 plus 4, okay, it makes 13. The next square number is 16. So 16 plus 4 makes 20. So now we can say that Tn here will take the square numbers, okay, plus 4. Okay, now question 5. We have 0, 3, 8, and then 15. Again, over here, we have 0 here. The first square number, we know it's 1, okay, but there it's 0. So, but to get 0 is like when we have like 1 minus 1, isn't it? The next square number is 4. After 1, it's 4. To get 3 minus 1. The next square number is 9. To get 8 minus 1. The next one is 16 minus 1. So this makes Tn equal to it's gonna be like n squared minus 1. Okay, thank you. So on and so forth. Okay, we can also do the same way. We can do question 6. That says -1, 2, 7, 14. Now we say this is when we find that it's a quadratic pattern. What we can do here, we see the first square number is 1, right? But to get -1, we need to minus 2. The next square number is 4. To get, we minus 2. The next one is 9. To get 7, we minus 2. And then 16 minus 2, we got 14. Then we can say over here, Tn equal to n squared minus 2. Okay, thank you. Well, we have another question here. Question C says determine the general term of the sequence that we see there. Now, we can look at the numerator and then consider also the denominator. So we notice at the numerator, for instance, square numbers are is 1, because as we did in the previous two questions, A and B, we noticed that those are quadratic sequences. So we will do, like, we look at the first square number is 1, and then to get 1, well, now we're going to do question C. The question says determine the general term of the sequence, the sequence that we have here. Now, we can notice that by looking at the sequence, we can see that these terms are squares of, actually, in terms of 3. This is like 3 to the power of 2, and 3 to the power of, this is like 3 to the power of 1, 3 to the power of 2, 3 to the power of 3, and this must be 3 to the power of 0. So definitely the numerator here, it is 3 to the power of what? N minus 1. I say N minus 1 because we started with 0 there. Now at the denominator, we can notice that it doesn't have a constant difference here. The first difference is not constant, but if you do the second difference, okay, as we did in question B and A, you notice that the second difference is constant. So we call it quadratic pattern. In this case, we're going to look at the square numbers that we know. The first square number is 1. Okay, to get 5, we plus 4. The second number is 4. To get 8, we plus 4. Same also here is 9 plus 4, and then 16 plus 4. Plus 4. Now we can notice that here the pattern will be n squared, because the sum of the square numbers plus 4. Therefore, Tn here we can say this is 3 to the power of n minus 1 over n squared plus 4. Okay, thank you.